Today we're going to be looking at how to overclock an AMD A8-3500M. For this you will need a few things, and you will need to understand a few things. First off, what is overclocking? Overclocking is when you take a computer from its original speed or frequency. This one is at 1.5 gigahertz and clocks up to 2.4 as turbo, and you change its multipliers and dividers, which we'll go over all that in a minute, to make it achieve a higher frequency. You can do this in two different ways. You can overclock or underclock, depending on what you're trying to do. Some people underclock to make their batteries last longer in their laptop, or to make their computer have a cooler temperature. Question is why you would want to ever overclock a laptop, and why overclock this 6-year-old laptop. Is it more beneficial or harmful than it's worth? Okay, the reason I'm overclocking this laptop is for many reasons. One, it's slower than I would like. When it first came out 6 years ago, it was plenty fast enough. I could go ahead and buy a new computer now, but there's a bunch of new CPUs and stuff coming out soon. So for the past 6 months to a year, I've been running mine slightly overclocked. Right now it is not, so that I can show you how. The risk involved in overclocking. Overclocking any CPU, whether it's a laptop or desktop, can reduce the life of your CPU, which can result in computer failure. Overclock at your own risk. If you do not understand anything mentioned in this tutorial, then overclocking may not be for you. Overclocking has benefits for gaming, for more enthusiast level, CPU intensive tasks, and for people that are just bored. Required tools for this setup: you're going to need a Leno-based AMD APU, which is what the A series of AMD laptops are. Well, the Leno is the first few generations of the Leno. Well, the first few generations of the APU. If you have a laptop cooler, then it's preferable to have a vacuum style, which hooks to the side of the computer and sucks heat out. I do not have one yet. Downloads that you're going to need at minimum: K10 stat, optional, which are useful downloads, a CP benchmark test of your choice. This way we can tell if you're benefiting in any way in performance by overclocking or not. You're going to need a CPU temperature tool so that you can keep an eye on your temperature. I already have one installed. Right now mine's running really hot for some reason. I'll have to figure that out in a minute. And a CPU tool that allows on-the-fly readings of your CPU frequency. I have not finished filling out this chart yet because I was going to wait and show y'all. So stock, I already said, was 1.5. Turbo is given at 2.4. Idle temperature, earlier I did this. It was a mid-50s idle. And under load, it was not this high earlier. It may be because I'm using this software to record this with. I don't know. I'll have to figure that out in a minute. Alright, so let's get started. First thing you'll need to do is download K10 stat. Just go to Google, type in K10 stat. It should pop right up. You saw it was the first option when you Googled it. Download the latest version. and this one is the August 6th 1.54 version. If you notice, it's a RAR file, or some people prefer calling it a zipped file. So we're just going to drag that to the desktop for right now so we can easily access it. Right click it. Depending on what you use to zip and unzip stuff, whether it's RAR or 7-zip, you need to extract it. Want to extract it to K10 stats folder. And there it goes. And that's it. Okay. So right now, I want to open it up. And you see right now that it's running at 1.5 gigahertz, which is fine and within range. And every one of these should be the same because I deleted the old one just to show you that I was doing it from fresh. Okay. Now the only thing you need to know as far as the profiles go is profile 1 will be activated on boot up. So if you want to have your overclock or underclock or whatever you do run at boot up, when you hit the button on your computer, then you want to set it as profile 1. If not, and you just want to run it sometimes, then you want to run it as any of the others, and you can rename them. First, I'm going to show you the two tools that I like using, which is CPU-Z. This will let me see the current frequency, which is 1.5 gigahertz. I'm just going to minimize that right now. And the thing that I showed you on the bottom right hand corner, it is core temp, but I don't know why it was running so high. Maybe it just wasn't updated. No, it's still saying pretty daggone high and pretty high utilization. I'm not sure why. Yeah. So hopefully we don't get any mixed results from what I've done in the past versus now with it already being a high temperature and a high CPU utilization rate. That's kind of worrying me. So to start out, we're going to get something to base all the future results off of. So this is, we're going to bench this CPU using a single thread as a reference. It don't really matter which one you click, it's going to give the same results. Okay, so we're going to get some really puny scores compared to some computers nowadays, but this is just a reference so we can tell if it goes up or down any when we overclock. Some pretty pitiful scores, to be honest. And yeah, I was getting a little bit higher earlier. Okay. Well, let's go back to K10 stat and we'll try to make this work. I'm going to put it as profile 2 just because I don't want to always use it. We're going to call it, we'll just call it overclock for now until I add some more profiles. Okay, FID is pretty much your multiplier. DID is your divider. Technically that stands for frequency ID and divisor ID, but it's pretty much your multiplier, divider, and your voltage. We're going to start at P6 and go up, because this is your frequency stepping up from 800 megahertz, 900 megahertz, 1000 megahertz, 1.1 gigahertz, 1.2 gigahertz, and so on. The B is your boost. That's your turbo. So we'll start out by changing P6. We'll change it to a 10 with a multiplier of 2. I mean a divisor of 2. And we're going to change the voltage to 0.9375. For P5, we're going to go with 12 with a divisor of 2. For all of these up until the boost, you're going to have a divisor of 2. And we're going to change the CPU voltage to 0.9625. P4, pretty much we're just going up by 2 for a little bit here. Got 14, 2, and we're going to go 0.975. Now how these values are determined are pretty much trial and error. If you applied these and then you stress test it and you got a blue screen of death or your computer shut off or something, it wouldn't be no big deal. You just have to restart your computer and adjust it to a lower frequency, or maybe a higher voltage, depending on what you change. With AMD, with this AMD one, it's a lot simpler, and you got less that you can change. If you had Intel, you can change a lot more and make a whole lot bigger difference. Okay, so resuming back to where it was, we're going to go 16 on this one. 2 again. And we're going to go 0.9875. That sounds good. 0.2. You pretty much just want to go in increments up, because you gain in frequency, so you get a gain voltage. I'm going to make sure. I did. Okay, yeah, so we're on a new one. So on this one, we're going to go 18. A divider of 2. And we're going to go 1.025. So now P1, we're going to start going up more. Let's go to 24. We're going to go to 2. And we're going to go up to 1.05. And P0, we're going to go way up. We're going to go the wrong way. We're going to go to 30. And then we're going to go set 2. 1.0875. For the boost, we're going to go 29 with a divider of 1. And we're going to go for voltage of 1.275. Don't sound bad, but we could go a little higher. We'll save that. If it crashes, we'll go up higher in the voltage. So 1.3, 1.4, 1.5, 1.6, 1.7, 2 gigahertz, 2.3, and 3. You want to make sure the boost is checked, otherwise you'll never hit a boost clock speed. You'll just leave the 60-20 alone. You want to change the up and down. This is pretty much a refresh rate. You want it to be no delay between states. You're going P6 to P5 and that, and in either order, up and down. You want there to be no delay. We're going to hit apply. Okay, so now it should be running. Yep, right now it's running 1.6. So right now it's at the P3 level, but it's not stressing out enough to really get it up there. Let's bench it and see if the score goes up from this. So we had 322 and 1078. Now let's bench it and see if it goes up. That is very odd. It actually went. That went down and that went up. It's very odd. I've never had it do this before. It always worked. For some reason, I think it has something to do with it's already running hot for some reason. But just for the heck of it, we're gonna try. I'm trying to go up with it. We'll just go ahead and let's change our tile. Let's change the voltage to 1.3 on the boost and the FID to 30. And we'll try that. I don't know if that's gonna make a difference or not. And let's switch it. Whoa. So it's going down. I believe that is down. I wrote it down, 329, yeah, it went down by a lot. Computer is getting pretty warm. Okay. Let's click it on the regular profile, apply it, and bench it again, see if it goes back up. Okay, so it went back up in the 1100s. So we're obviously doing something that I didn't notice. Let's go back here. And we're going to put it back down to 29 again. We'll leave it at 1.3. Just double check and make sure I put in the values that I meant. 30, 2. Well, everything 18, 16, 14, 12, 10. And that is very odd. Let's try it one more time. I have had good results with this before. But today it is not. So the conclusion to what just happened, okay, yeah, it did finish. The only reason that that would happen is because you see how it's running at 91% and the temperature is at 86 degrees, which is extremely hot. You really never want it more than 80. You can keep it under 80 is always good. You never want to hit 100. 100, you pretty much want to turn your computer off if it doesn't automatically shut off at 100. The only thing I can think of, the reason, maybe to snag it or whatever this program I'm using to record this with, is taking a lot more resources than I thought, because I have had way better results with this before. But for the heck of it, we're just gonna play around with it now, because obviously I can't do nothing now as far as showing you a massive increase in scores. So let's just see if we can get the temperature to go way down. Let's play with this one. We'll start at we're just gonna keep them the same and go down on the voltage, because AMD a lot of times supplies theirs with just a little too much voltage. So I'm just going to go down one selection at a time. So that one, I went down to 0.925. This one I'm going to go keep it there. And this one, and let's go back. Let's go down one more. Hopefully it don't shut off on us. And that. Just going down one step at a time. So the next one above 0.925 would be 0.9375. Next one, 0.965, be 0.965. Just go down one. 0.975. 0.965. 1.0. 1.01. So we'll go 1. 1.0375 what's that? So we'll go down to 1.025. And 1.3 we'll go ahead and 1.2875. Hopefully it don't shut off on us. Temperature should start dropping. Might take a minute. It's got to dissipate all that heat that's already built up. Let's think it until it does. I'm expecting a smaller score than before, or for it to shut off, either one. It's actually very, very similar. Oh, well, guess I could change that. Yeah, that's what I was figuring. I was figuring it to be even lower. But it ain't too much lower, which is surprising. So depending on how much the temperature actually drops from that, it might be worth it. I have no clue why it's running so hot. That is driving me crazy. And there's no way we're using that percentage of a load. Well, for the purpose of this video was to show you how to overclock an A8-3500M by using this P-state table and adjusting the values. This is how you overclock an AMD APU chip. Is it worth it? Well, obviously, if you're running something as hardcore as whatever this Snagit thing is that I'm recording with, then no. You're actually losing performance. Now, does that mean overclocking is never worth it? No. If you got sufficient cooling and you can keep your degrees in Celsius down, then overclocking can be worth it. For example, we overclocked my uncle's computer that we just built, and I think I still have it. Yeah, here it is. And the scores that we got with it before overclocking was 2,000 and 9,000. So much more significant than what we gained here. Now after overclocking his, we easily reached 11,000, 12,000. But with all that being said, on a laptop, pretty much if your computer is no longer staying as fast as you need it, and unless you buy a laptop cooler and want to keep it on laptop cooler all the time, then there's pretty much no use in overclocking it, because you're going to need to carry around a laptop cooler everywhere you go, and it's no longer going to be portable. So for my verdict, I say overclock only on desktops, because you can easily provide enough cooling with water cooling or a giant air cooler, different case designs, etc. Laptops, I say only overclock it if you're using it as a machine that stays at home and you don't take it anywhere with you. That way you're not having to carry around a laptop cooler with you everywhere and risk hurting your computer or running really high temperatures. With that being said, overclocking on this laptop is not worth it. Now, before, I had gained about 5 to 800 on the single thread performance, but today we're not getting that kind of performance because the temperature is not staying where it needs to be, and the utilization rate is not staying where it needs to be either. It's saying that it's running almost 100% of its capability, which is not true. But the reason it says that is because we're taking that base clock of 1.5 and a turbo of 2.4, and we're setting it slap dab in the middle to begin with. So that's the conclusion of this